Good morning to all. In lecture series on research methodology, today we are taking the topic statistical data analysis for science faculty students. Myself, Dr. V.C. Kakade, Department of Statistics, Tulzaram Chaturchanda College, Baramati. My outline of talk: why statistical data analysis, formation of hypothesis and statistical hypothesis, role of statistical software in data analysis, and case studies along with data analysis tool in mathematical science and life science. Now, why statistical data analysis? Now, in research, researchers develop the new ideas, some study of specific area. Some researchers are interested in comparative studies. Also, some researchers develop a different specific or generalized models. Some researchers are interested in classification studies. Also, some researchers study some dispute events and also a study of some historical events. Now, why the need of scientific statistical methods? Now, by using scientific statistical methods, we can justification or justify our new ideas or our findings. Now, in research, every has everyone fix their objective because without objective there is no research. So if there are objective, then it is necessary to convert this objective into the hypothesis. So this is called as a simple hypothesis because this hypothesis is expressed in simple language which has a guaranteed meaning. For example, suppose I consider simple example. Suppose I am interested to test whether there is a large number of literate peoples in a Baramati. This is my research topic. Whether there is a large amount of peoples are literate in Baramati. Now, how this we measure that the majority peoples are literate in Baramati? So, my best knowledge in my research, I fix that if around 85% peoples are literate, then I can say that the majority peoples are literates in Baramati. So my hypothesis is what? The around 85% peoples are what? Literate people. Now this hypothesis has a guaranteed meaning. It has no dual meaning. So this hypothesis can be written in terms of what? Statistical hypothesis. In statistical hypothesis, we can write in terms of mathematical equation or mathematical formulation, which has some probability distribution background. Now suppose I say H naught capital P is equal to 0.85. Now this capital P denote the proportion of literate people. So my statement is what? Capital P is equal to 0.85. Now every hypothesis which has a guaranteed meaning is called as null hypothesis. So if we fix a null hypothesis, then it has a negation or inverse of this statement. It is called as what? Alternative hypothesis, which is denoted by what? Capital H1. So what is my capital H1? That P is not equal to 0.85. So what is my H0? That capital P is equal to 0.85 versus what is my H1? That P is not equal to 0.85. So this is my statistical hypothesis. So for this justification of this hypothesis, whether the hypothesis H0 may be true, otherwise H1 may be true. So we need some statistical methods or statistical tool to verify this hypothesis. Now, formation of the hypothesis or statistical hypothesis, we already see the difference between the hypothesis and statistical hypothesis. Now, how collect the relevant data corresponding hypothesis? Many researchers collect the data, but when they analyzing the data, then they feel that I have not collected well organized data corresponding to my hypothesis. And many times their study fail. Otherwise, they have to recollect the data corresponding to the hypothesis. So please note that you must collect the relevant data corresponding to the hypothesis. Now, how we collect the data? This is already discussed in previous lecture in sampling methods. Also, how we collect the data corresponding hypothesis is also discussed in next part. Now, many times the researcher is interested in analyzing the data, but he feel that it is a very complex or critical process for the data analysis. But this is not critical process or complex process in a data analysis because there are many statistical softwares are available for analyze your data. So we see what is the role of statistical software in data analysis. First, there is no need to design a special form of a data file. Majority researchers know the MS Excel, which is a worksheet, which is a collection of rows and column sheet. So we can fill the data column wise, which is collect from your experiment. So from this Excel data, we can import or export this data to your statistical software. Second, many researchers they are worried about the statistical formulas, but no need to recall the statistical formulas. Only you know what is statistical formula. Only need of basic concept of statistics and statistical methods. Means what? You have to know which statistical tools are available, which statistical method is specially designed in a specific purpose. You only know these basic concepts, then you can analyze your data by using the statistical software. Now, next is output is very easy, which gives by the statistical software because this software gives a output which is very easy to understand. Next, excellent graphical and diagrammatic presentation gives this statistical software. Because we know that for the exploratory data analysis or a rough idea about the data analysis, we need a diagrammatic and graphical presentation. So this is also achieved in this statistical software. Now, what are the list of statistical software? Now, first, MS Excel. What is the use of MS Excel? We can collect or condense the data by using the worksheet in Excel. Also, some simple statistical tools are also available in MS Excel. There is one option, data analysis in MS Excel. By using this option, you can do majority data statistical tools for the analysis purpose. Now next is what? SPSS. Now what is meant by SPSS? The software name originally stood for Statistical Package for the Social Science. So it is called as SPSS. So reflecting the original market, then they later changed to Statistical Product and Service Solutions, which is especially designed for the social science. But now we are related with science faculty group. So can we use this SPSS software for data analysis? Yes, you can also use this software which experiments which are conducted in a life sciences also and also mathematical science also. So this software also easy to compute the statistical things. Now another software is what? R software. What is the specialty of R software? This is freeware. What is mean by freeware? Because your MS Excel, SPSS and another statistical softwares, they are not free. You have to purchase this software. You have to purchase license software. It is very costly. But this R software is a freeware. Any researcher can download this R software from Google. So what is the beauty of this R software? Because this software is also used for the learning the statistics. Also, this can be used as a data analysis purpose also. It has excellent graphical interface and it is easy to handle the data. Means what? You can import the data which is stored from Excel to R. So this is very famous software and it is a very freeware software. Now another software is what? Minitab software. This is also licensed software. You have to purchase it. So the purpose of Minitab is also excellent data analysis facility and graphical interface and easy to handle the data. Now next statistical software is what? ITSM, an interactive time series modeling package for the PC. Now this software is specially designed to analyze the time series. Now what is meant by time series? That the data which is generated with respect to time, it is called as what? Time series, which arranged in chronological order. What is meant by chronological order? Chronological order means with respect to time. Time means what? It may be day, it may be week, it may be year, it may be month, it may be minutes, it may be second also. For example, suppose in life sciences or microbiology, you are germinating or you are observing or you are interested in germination of some viruses or some species. So this may be grow with respect to minute also, in hour also, in second also. So this data is related with what? Time series. So this software is easy to handle a time series data. Next, tools for data analysis. Now, which tools are available in statistical data analysis? When you collect your data, your aim is what? To analyze the data analysis for the your given objective, which is a translated in a hypothesis. And then you again this translate this hypothesis in terms of what? Statistical hypothesis. Now, in analysis, the first part is what? That diagrammatic and graphical presentation. What is the achievement of the diagrammatic and graphical presentation? It gives the rough idea about the data. From this diagrammatic and graphical representation, you can get many relationship between the two things. Suppose, for example, with respect to time, some species are rapidly increasing. So, what is the trend of that generating the species with respect to time? Is there any relation between this time and generating the species? So, such a type of things you can observe. Many times we have know the relationship between the two things. So these hidden things can be get from the diagrammatic and graphical presentation. Many times bar diagram, multiple line diagram, pie diagram, box plot, histogram, normality plot, these diagrams are used for the what? Primary data analysis. Now, second part is what? The second part is after the rough idea about the data, now we have to criticize your analysis by using the statistical data analysis tool. So there are some simple tools that which is called as descriptive statistics. Suppose if we collect any data, then everyone or every researcher has to do the descriptive analysis. Now, what is the descriptive statistics or analysis? In this, we measure the measure of central tendency. We know from the seventh standard what are the measure of central tendency, mean, mode, median, and so on. So, what is the measure of central tendency? It gives the central idea about your data. What is the average? That suppose we are collecting some data, specific data. So we always interested in that average. Now next is what? Measure of dispersion. So measure of dispersion gives the variation among the that your observations, your data. By using the dispersion, we can analyze what is there the homogeneous data or it is the heterogeneous data. This can get the idea by using the measure of dispersion. So what are the measure of dispersion? It is what? It is variance or what? It is a standard deviation. Now suppose we consider one example from the botany. Suppose they are interested in a height of plants. Suppose they consider one experiment in lab. Suppose there is a tree and they are observing around 1 meter and they get the 100 plants height individually. Now suppose they want to taking the general or rough idea about the that your height of the plant. So what they do first? First, they find a simple major center tendency, that is the mean. Suppose mean is what? 5 centimeter. Now suppose that researcher is also interested that the average height of the plants is 5 centimeter. But that researcher is not get the idea that the average height of the plants 5 centimeter. It has a no strong evidence that it maintains the height of the plant is 5 centimeter, as well as he has to also study about the variation. So for variation, they have to find the variation or variance of that the height of plant. Suppose I find the variation and I take the square root of variation, then I can get that the standard deviation. Suppose I get a standard deviation 2.5 centimeter. It means that there is a variation of 2.5 centimeter among these trees from the central tendency, that is the arithmetic means. It means that there is a large variation in what that the height of the plant. Suppose I get a standard deviation 0.25 centimeter. It means that what there is a less variation in the height of the plants. So such a type of analysis can be do by using what? Descriptive statistics. You can also get a skewness of the data, whether it is a positive skewness, whether it is a negative skewness, whether it is a symmetric data, you can get the skewness of the data. Now in this example, we get the skewness as a symmetric distribution for what? Height of the plants. Now, next statistical tool is what? Correlation and regression. Now, why correlation we use? Suppose we want to measure the relationship between the two variables, then we have to use correlation. Okay, suppose number of days and height of the plant. Suppose I am interested if the number of days are increasing and also the height of plant is also increasing. Is there any relation between the number of days and the height of the plants? So this can be achieved by using the Karl Pearson correlation coefficient. If this correlation coefficient is close to 1, means what? There is a highly positive correlation coefficient, means that if number of days are increasing, then also the height of plants are also increasing. So if we get a considerable correlation coefficient, then we always goes to the regression analysis. Now we also see some after some 3 to 4 slides that which type of regression you can fit. So this can be discussed in some afterwards. Okay, so these are the type of the regressions are also there. Which type of regressions you can use here, we can see afterwards. Now next is what? Testing hypothesis. Now, what is the testing hypothesis? There are various tests are available in statistical data analysis. For example, t-test, pair t-test, f-test, chi-square test. These are the tests which are available. We can see the role of this statistical test in case studies. Now next is what? Design of experiments. Suppose we have more than two groups under the study. Okay, suppose we have more than two groups under the study. Suppose there are three plots are there, and these three plots we are growing some crops. And suppose we are interested in a yield of crops in these three plots. And my research is what I am interested is what whether the average yield of these crops are same or not same. Now here we are comparing more than two groups at a time, so we cannot use the testing hypothesis, so we have to use the design of experiment in this case. So we also discussing some case studies related with what? Design of experiment. We already talk about the time series analysis. Now, case studies among with the data analysis tool for mathematical science. Now, case studies from the chemistry and physics. Now, many times in chemistry, we perform the titrations. And in titration, in a single titration, we never conclude about the your findings. So we always replicate these titrations. Generally, we replicate this titration thrice. Why thrice? Because if we take a first titration, then consecutively again we take a second titration, then there is a less chance of the observation of the titration is very close to each other. So for this, for confirmation of this observation, we take a third iteration and then we conclude our the remarks. So replication is always necessary in such a type of the experiments. In physics, in chemistry, in microbiology, we use many equipments for the measurement. Suppose if your equipment is not giving the consistent result, then your research may be wrong. Otherwise, you are not getting good results. So, the first thing is that you have to check the consistency of your equipment. Suppose your pH meter is there, vernier caliper is there, and so on. So, first you have to find the consistency of the equipment. So how we measure your equipment is a consistent, that is, there is no variation in your equipment. This can be measured by using the standard deviation and coefficient of variation. Whether your voltmeter is working consistently, so this can be checked by using the coefficient of variation. Development of new efficient models. So what are the models are available? I already talked about the regression models. So it may be linear model, it may be logarithmic, it may be exponential, it may be power, so on. So we will see some examples or case studies about this model afterwards. Now, electronic components or any components. So in statistics, there are few distributions like exponential distribution, Weibull distribution, normal distribution. So by using this exponential study, we can study about the lifetime of the electronic components. So it has a great role of this distribution in lifetime study or any component's lifetime can be assessed by using the application of exponential or Weibull distribution. Many times the normal distribution is also useful in this study. So there is a reliability theory in statistical literature. This is very useful for the lifetime or working of the electronic components. Now I consider one case, that is the X and Y. Now here I consider Y as my dependent variable and X, it is my what? Independent variable. Means what? In any bivariate case, one variable is always independent and another is also what? Dependent. We are interested in estimate the value of y by corresponding value of x. Suppose this is my data and I'm directly say what will be the value of y when my x is 3.8. Can you give the some estimated value? No. By visual judgment, we cannot give the estimate value of y when my x is equal to 3.5. So you have to study about the trend of this x and y values, whether there is a relation between the x and y. So first, how we find the relationship between the x and y? We know that we have a correlation. Is there relation between the x and y? Yes. If there is a relation, considerable relation between this x and y, then we can go for the modeling. Suppose there is a considerable relation between the x and y. Now I am going to fitting us various models. Suppose by using MS Excel, there is a scatter plot option is there, and by using this scatter plot, there is an option of linear trend or linear curve. What is meant by linear equation? That is y is equal to a plus bx. So 0.845557 is my what? A, and minus 0.3669 is my what? B. Now your statistical software, it gives the linear equation. This is my linear equation, minus 0.3669x plus 0.8457. Now what is the support for this equation for your given data? So this is the support, that is the r square, which is 0.8314, means what? 83.14%. It gives the support for a corresponding data by using what? Linear curve. Okay, suppose anyone can try for the another model also. Now my data is the same and my using another model. Suppose I use a logarithmic model, that is the logarithmic curve. Now what will be the, I get that the equation that y is equal to minus 0.321 log of x plus 0.4026. Now what is the support? That the support is 97.82% is a support for the what? Logarithmic curve for a corresponding my data. My data is same and I'm using the different regression models. Now this is my logarithmic model. Previously I see linear model. In linear model I get a 83% support for same data. For same data by using logarithmic curve, we use how much support? 97.82 support, 82%. Many times in physics, we draw a various graphs and we try to find a freehand curve corresponding these various points which cover the maximum points. So this is your rough idea about your trend of the data. But by using the statistical software, it gives a mathematical model for corresponding this data. Now next, suppose for same data, I fit an exponential curve, then I get an equation y is equal to 0.9656 e raised to minus 0.83 into x. So what is the support? Here I get a support of 95.59% support. Now we consider the power curve for the same data, then I get y is equal to 0.3639 x raised to minus 0.665. Now what is here support? We get a 94.21% support for the power curve for the same data. So if we observe these four curves, then we can easily justify that for my given data, logarithmic model is a suitable model. It is a best fitted model. So such a type of analysis or trend analysis can be do in your research. Don't draw a simply a freehand curve for the corresponding data, but try to fit a various type of models or mathematical models for that data so you can estimate things. So how we estimate now? Suppose I say previously, I am interested in finding the value of y for x is equal to 3.5. You have to simply put the value of x 3.5 here and calculate the value of y. So this is the best fitted estimated value for the corresponding your data. So this is a role of models for the from the statistics. So there are various case studies from the statistics. Now we see some case studies from the statistics. There are some case studies from statistics. I will not discuss these case studies in detail because the students from the master degree statistics are already familiar with the statistical methods. But nowadays, there is huge demand for statistics students in the clinical trials, marketing, business and finance, and IT industries, and so on. So the students has to take the projects from these areas. Now, what is meant by clinical trial? Nowadays, we are facing the effect of crisis of corona. Because of corona, there is a serious effect on human life as well as social life and economy of India as well world. Today, we are waiting for the preventive vaccine on the corona. Now, why there is a late for the vaccination on corona? There are many reasons behind this. The first reason that every new vaccine must be approved by WHO. WHO gives the permission to introduce new vaccine if this is safety as well as efficacy. That is, only effective is not important, it must be a safety also. So this can be verified by using the clinical trials. There is a restriction on pharma companies. They have to introduce the new vaccine after conducting the clinical trials. Clinical trial is a scientific method. By using this, we can verify whether the drug is effective and safety. So, statistics has an important role in clinical trials to design the experiment and analyze the data. So, the students from the master degree can take the projects from the clinical trials also. Now, there are many IT industries are there. Nowadays, data is generating very rapidly. Data may be in terms of numeric, text, image, videos, and so on. So such a type of data is generated on Instagram, WhatsApp group, Twitter, Facebook, and so on. This data is called as big data. So there is need to analyze this data. So my appeal to the master degree students from the computer science as well as statistics, so they have to take the project belongs to this big data analytics. Also for statistics students, they have to they have to perform the projects from the insurance as well as also the banking. So there is tremendous demand from the projects from actuarial statistics also. So this is the request or for the students from the statistics. So they have to take the project from these areas. Before 10 years ago, we performed one TYBSc project on a study of rainy nakshatras from Baramati and Bhorwadgar dam region area. We consider the problem that how our study is useful for the farmers with the help of consistency in rainy nakshatras. On this project, we published 3 research papers in well-known journals with different statistical views. So this paper is also presented in national conferences. So they comment us that this study is very innovative. So my appeal is that you have to consider some innovative projects, research project, good quality of the research. Now, case studies from the computer science. Now, in each and every time, we unable to perform the experiment each and every time. So the simulation study has a tremendous demand in the area of computer science, mathematics, and statistics also. There are new areas of the research by using the tools machine learning, deep learning, artificial intelligence, text mining, image processing, classifier study, and so on. So my request to the master degrees from the computer science and statistics, they have to perform their research on the basis of these new techniques. Now, I request to the Akhilesh Kakade to present his research work on the situation of a nerve detection, which is based on virtual reality model. So I, I, I request to the Akhilesh Kakade, please present his presentation. Thank you.
Hi everyone, this is Akhilesh Kakade from Baramati. So right now I work in SAP Labs Bangalore as an associate developer. So today I'm going to share one of my project which I did in my BTech, and later on I did more research on it and published my paper in IEEE during my MTech. So my research title was Identification of Nerve in Ultrasound Images using UNet Architecture. So basically this was the project related to machine learning, or I would say application of artificial intelligence in the medical field. So introduction. So as we know that surgery is considered as an undesirable process which causes a short term to the patients. So to reduce that short term pain, doctors usually used anesthesia, right? So in the medical field, there is a concept called regional anesthesia, which has been used to inject the anesthetic to the nerve location so that it can immobilize the part of the body of the patient. So to use this regional anesthesia, the doctors use the ultrasound images so that they can get the information related to the anatomy of a particular patient into the surgery. So in this paper, we are using a supervised method to identify a nerve in an ultrasound images of the part of the neck region, which is called as brachial plexus. So basically, there is a nerve which goes from neck region to the armpit, which is called as brachial plexus. So doctors usually gives the anesthesia to this nerve, and the goal of this project was to detect that nerve location into the ultrasound images using supervised method. So literature survey. So basically, in literature survey, we do the study related to the paper based on the same idea. So I would just tell you the overview, like the ultrasound guided regional anesthesia. So this is the one of the technique which is applied during the anesthesia. So this is a long-term process. So in which the doctor or the radiologist, based on their skill, they detect the nerve of the location into the ultrasound images. So basically, when you go to the radiologist, so they will have a, ultrasound scanner and they will scan the region with the help of that scanner, and they with the help of their expertise they will detect the nerve. So in this project what we did with the, so there is no any need of a radiologist or any doctor. So then we'll pass the ultrasound image to the deep learning model, so it will directly give you the location or the exact location of the nerve in the ultrasound images. So data description. So for this project we had 42 patients data, uh, so male and female both. So as you can see, the left image is the train image, which is the original ultrasound image, and the right image is the labeled image. So this labeled image are being annotated manually by the experts. So here the white region is called as the region of interest, where the nerve location is present. Okay, so these are the information or details about the image data, like what was the image size and all, around 580 by 420. These were the training images, so we had around 5600 training images, 5500 testing images for it. And as we know that uh, while approaching to any machine learning problem, first of all we need to understand the data. So data understanding is really important, like what is your data, are there any noisy images, are there any repetitive images and all. So you need to filter it out using pre-processing and all, and later on you can pass to the model to train the model again to do the data analysis and all, again retrain the model and all, and to get the good results. So in our methodology, the first step was the pre-processing. So our pre-processing, as we have a noisy data, we used Gaussian filter. So Gaussian filter is basically used to smoothing the image and to remove the noise from the images. So basically, it is used to extract the hyperchoic, that is the regions which are brighter than the normal, and the hypochoic region which is darker than the normal. So basically, the Gaussian filter we used to remove the noise from the image. So as you can see, this is the original image, and Gaussian filter, after using Gaussian filter we have this smooth image. So after that, to classify it, we used k-means clustering. So basically our interest is in the foreground region, not in the background region. So to classify the foreground and the background region, you to classify each pixel we use the k-means clustering. So as you can see, so we had foreground as well as the background image. So after that, after using k-means clustering for feature extraction, we still have the noisy images or noisy pixels into the images. So for that, we use the Gabor filter. So Gabor filter is used to reduce the effect of noise and also to enhance the edges in the artifacts of the images. Basically, the Gabor filter is used is a bandpass filter to detect the edges of the foreground images. So I will show you it. So as you can see here, after using k-means clustering, we use the Gabor filter. So as you can see, the edges are being detected for the foreground regions here. Okay. So after that, to get the exact features, so one of the features we use for considered for detecting the nerve was the pixel intensity. So we used one technique called as LBP, that is a linear binary pattern. So linear binary pattern basically tells us the pixel intensity present in the image. So this pixel intensity denotes the region where the nerve must be present. So this was one of the feature we considered, linear binary pattern. So after that, for classification, to compare the or to get the exact features, we used a approach called sliding window for classification. So basically, we had a training data which contains a original trained data, the original ultrasound image, and accordingly we have a corresponding mask image. So as we know that pixel value ranges from 0 to 255, right? So what we do, we have, I will show you the diagram here. So in this sliding window approach, as you can see, so what we do, we carve out a window in the original image, which is called as W. Consider it as a W. And similarly, same window we carve out into the labeled image, which is called as W mask. So what we do, we compare the pixels in both the images. So basically our aim is like to get the probability. So what we do, we calculate the probability of each and every region pixel wise, and we try to find out the such kind of pixels which has the region of interest. So what we do, we compare the pixels in both the images. After that, we shift that window by 1 pixel. So this shifting process is called as the sliding window process. So for example, consider that this window comes to this white region similarly in both the images. So what it does, it calculates the probability. So as we know that probability is between the interval 0 to 1. So we set a threshold t. So what we do, if p of pi is greater than equal to the t or the threshold, then that pixels belong to the region of interest. Or if this p of pi is less than t, less than threshold, then it doesn't belong to the region of interest. So this is the sliding window proposal, I would say, in which we were able to identify the exact features of the nerve, which it helped us to train the model. So after the sliding window proposal, we used our neural network model, which is called as UNet architecture. So this looking at this diagram, we can see it looks like a U-shaped architecture. So basically, UNet architecture is a convolutional neural architecture, which is used for image segmentation and all. So this is a segmentation problem basically. So this architecture consists of two types, like the two parts I would say, like encoder and a decoder. So what we do, we resize the image, the original ultrasound image to 128 by 128, and we pass it to this unit architecture model. Then what we do the downsampling or the contraction. So what we do, we reduce the size of the image by 128 by 128. After that, 64 by 64, 32 by 32, 16 by 16. After that, at last 8 by 8. And simultaneously, we pass these vectors to the upsampling part. So what we do, so in this process we have what and where. So what means what is like what are the features present in this image and where it got lost, because as we know that during downsampling there are majority chances like we can that the feature may lost. So to avoid that, what we do, we again it goes back again, it learns the features which were lost. So due to this processes, the model gets to learn about the features which are present into the nerve. So as I explained here, we have two parts, encoder and decoder. So this is the overall explanation of the unit architecture. Yeah. So after the so basically after passing this image, so as you can see here in unit architecture, we pass a ultrasound image, and in the output we get a binary mask. So this binary mask may be blank. So if it is blank, it denotes like there is no any nerve region present. So if contains a white region, so that white region is called as region of interest. So that is the exact nerve location. So after training this data, we get this kind of results in the left image. So this image is somehow, as you can see, there is a discontinuity in the mask generation, because our aim is to get the exact annotation or exact location of the nerve. So we need to reduce this white region, right? So for that, we are using a post-processing technique which is called as PCA, Principal Component Analysis Based Cleaning. So what we do, we have a PCA-based model. So we pass these labeled images or this binary mask images, I would say, not the labeled images, the binary mask images to this PCA model, and we get the eigen mask. So due to this, what we get, we this PCA model reduces the dimensionality of this image. So what it does, it reduces, as you can see, the right image is the output of the PCA transform mask. So this white region got reduced. So this is the exact location of the nerve. So this was the post-processing technique which we used. And to measure the accuracy, we use the dice coefficient. So dice coefficient is used as an error measure, and this is the equation for it. So this is the result. So this is the real-time application of our model. So as you can see, this red circle denotes the nerve location. So wherever there is a nerve location present, it denotes by a circle. Yeah. So, and this was the results which we got. So this different experiments we did. So, and this was the die score here. So without any pre-processing and post-processing, we achieved up to 0.53. After that, with sliding window classification, we our results got improved by 0.56. Then we added the autoencoder and decoder. We got up to 0.62. Then again with unit architecture, without PCA, without post-processing, we got up to 0.66. And finally, unit and with the post-processing, that is the PCA, we achieved the result up to 0.68. Yeah, so thank you. So this was the overall overview of my project. So the main goal behind this, like to inspire you, like you can also do this kind of machine learning based projects, and you can publish your paper into the good research papers like IEEE, elsewhere and all. So this paper I published in IEEE in 2018, and I got 3 citations for this paper into the international journals and all. So I would like you to get inspired and do such kind of projects.